Welcome back, ladies and gentlemen. Mr. Hescox here, talking to you about physical science. We're still in the beginning principles of physical science today. The opening question, what is a force? So when you think about that, give me the definition. If you have time, give me the example too. So you should have already done your question in Google Classroom. A force is a push or a pull, or the ability to cause something to happen. An example of a force could be pushing on a wall and the wall pushes back, or you could close the door. You could throw a baseball. Any of those would be good examples of force. Today we're going to start talking about scientists, how they think, how they solve problems. We call that the scientific method. You've got a little bit of reading tonight. That is Roman numeral pages 38 to 41. I would like you to write out a little paragraph about a project or experiment that we could do that follows the steps of the scientific method. What do you think of when you hear the word scientist? When I think of scientists, I loved The Big Bang Theory when it was on TV. Are those the first things that come to your mind when you think of scientists? What else do you think of? Do you think of microscopes, lab coats, experiments? Doesn't always mean just that. The true characteristics of a scientist are that they have to be curious. They ask questions and want to investigate to find the answers. Scientists are observant. They look very closely at the details. They take data, very accurate data, to make sure that their ideas have proof. Scientists are creative. They are going to use what they know to try and solve or come up with explanations for things they can't. And then obviously scientists are skeptical. They don't accept an explanation without proof. There has been all kinds of talk about Bigfoot on Wapsie Mountain. Well, guess what? Until a hunter drops a Bigfoot, I'm not buying it. Make sure that you check out this little video. It's by Koma Nitty. He does a lot of science videos. It's really good. The steps of the scientific method. Now, these are a little bit different because I wrote them to match up with your book. When I use them in class, I'll present them both ways. First step of the scientific method, you must have a question. It can be the question of what type of cup will keep my coffee warm the longest. Then you're going to research. That's called determine what is known. We research on the internet. We research in libraries. We go look at encyclopedias, things like that. Eventually, we investigate. The investigation has some parts. The first thing is once you know what you're going to research, you come up with a hypothesis. A hypothesis is the answer for the question of what you came out with. But you don't know the answer necessarily. It's what you think is going to happen. It's a prediction. Like if you go to a psychic, they always look into their crystal ball and think this is going to happen. Then we run the experiment. An experiment is going to be used to say, this variable caused this to happen. It could be how much water allows plants to grow the best. It can be, can I add substances to water to make plants grow better? And how much of that substance? Then you would take your data, basically how much of each growth happens for each plant. We call that interpreting results. Today in modern science, all of our results are going to be graphed, and they're going to be graphed electronically. We will make electronic graphs frequently in this class. It makes your data neat. It makes it very easy to read. And it's also one of the PA state standards to be able to graph electronically. And then finally, you have a write-up where you share what you found. Was your hypothesis correct? Was your hypothesis wrong? Why was your hypothesis correct? Why was your hypothesis wrong? These are the kind of things that you have to think about, and you write and you share those with other scientists so they can redo your work.